Hi. So in this video, in this question of the week 5 math prepare, let's review the multivariate chain rule again. So the multivariate chain rule is used when we want to compute a derivative like this one, but where our quantity x1 affects m through two different ways. So here h1 appears when we compute both y1 and y2, and both y1 and y2 affect m. So we've got this situation kind of like what we have here, where we have a function f that depends on x and y, but x and y themselves depend on some quantity t. So this derivative right here, and remember, derivatives are rates of change, right? So this derivative is really asking the question, how much does f change when t changes by just a little bit? And while the way that a change in t is going to affect f is going to be through this path, through x, and also through y. So we need to add these two components together. Last week, we had a question in the prepare using the multivariate chain rule, and this will be a great opportunity to see how to apply the multivariate chain rule. So let's review last week's content, last week's question. So last week, we wanted to find this particular derivative right here. And one way that we can visualize what's going on is by just drawing out how are these quantities, how do these quantities that we see on the screen here affect L? And let's start with H1. So H1, that's the denominator, that's the quantity here that we care about. H1 affects both Z1 and Z2. Z1 and Z2, they both affect Y1. They actually both affect Y2 as well, although this top part is really what we care about because Y1 affects L, and this derivative L with respect to H1, that's the derivative that we care about. So we don't necessarily need to draw this picture, but this picture is a nice overview of what's going on. So let's see how we can apply the chain rule, the multivariate chain rule. So we want to know the derivative of the loss with respect to H1, that's our desired quantity, and we can decompose this derivative into two parts. So this is just the chain rule. So for derivative of the loss with respect to y1 and derivative of y1 with respect to h1. So nothing fancy here. Y1 affects L only through one path, so we don't need to do anything fancy. So now the interesting part is now this derivative term. So this derivative term kind of looks like the picture that we had earlier, where h1 affects y1 through these two different paths. So we're going to need to add together derivative of y1 with respect to z1 times derivative of z1 with respect to h1. And the other component, the dependency of y1 on h1 through the z2 term, z2, h1. So that's really all we need. Now what's left to do is to compute these derivatives. So let's take a look. So this derivative right here is, it actually looks pretty straightforward. L is log of y1, so the derivative of L with respect to y1, that's going to just be 1 over y1. These two terms are also fairly straightforward. We can just read them off directly. So W11 and W21. It's really these two remaining terms that are a little bit more involved. So let's look at those, and we'll look at those fairly carefully. So first one, derivative of y1 with respect to z1. So we're going to need to use the quotient rule here. So the quotient rule tells us that the derivative of a quotient is, well, derivative of the numerator times the denominator minus the derivative of the denominator, e to the z1, times the numerator, so e to the z1 again. Divide by, we've got the numerator, the denominator squared. So now I've got this term. I'm going to pull e to the z1 out from the subtraction here, so e to the z1, and then I've got e to the z1 plus e to the z2 minus e to the z1 at the top. And these two parts cancel out. And I'm also going to do something weird here, which is I'm going to write out my sum twice. My two terms at the bottom. So I've got this square, right? So I'm just writing out this term twice. What that allows me to do is to group these two parts together. And we can see that this part right here, well, that's just y1. This part here, well, that's just y2. So that tells me that this entire product is just y1 times y2. So this right here is y1 times y2. All right, now let's look at the other derivative. So I'm going to clear up some space here. And let's compute the derivative of y1 with respect to z2. So this term right here. So same thing, quotient rule. So derivative of this quotient is derivative of the numerator, so e to the z2, times the derivative of the, so the derivative of the numerator here is 0. So 0 times the denominator, right? Because the derivative of e to the z1 with respect to z2, well, that e to the z1 doesn't depend on z2 at all. All right, so now we've got the other term, which is the derivative of the denominator. That's going to be e to the z2 times the numerator, e to the z1, divide by, what do we have? Numerator squared. And right away, I am just going to write out the denominator squared twice rather than using the square term, because this term just disappears. And once again, I've got this term here, which is y2, and this term here, which is y1, and negative sign here. So this derivative term is negative y1 times y2. So we can do some simplification here. So let me make some space again, and let's do some simplification. So I'm just going to write out all these terms here. y1, this is times y2 times w11 minus y1, y2, w21. So the 1 over y1 cancels with the y1s. And now I can pull out my y2, w11 minus w21. And we have our answer.